Okay, if we continue on with this, now we're looking at use polar coordinates to find the volume of the given solid below the paraboloid and above the ring. So we have this paraboloid that's running I should have made it wider just so we could see it. So of course it's not this wide, but not trying to scale. There's that paraboloid. So below this paraboloid, above the following ring. So something like that. And here, of course, it's hollow on the inside. So if I look at it in the 2-dimension, I will see color. Okay, I'll get it right. And let me move this down a bit just so that we can see it better. Okay, so this circle with radius 1 and this circle with radius of 3. And we're talking about this region. So volume is going to be the double integral over region R. Let's not use R. Let's use D or E. Of top minus bottom. Top is really x squared plus y squared minus the bottom is really 0 and dA. And what that would be, so we know this is r squared, r d theta. We know that theta is going to run all around, it doesn't say in the first quadrant, 0 to 2 pi. And r would run simply from 1 to 3. And that's pretty much it. And that's a simple integration, r cubed, add 1 to the power, divide by that, and proceed. And from what you know from the previous section, this would be a hassle if you wanted to use equations of circles. This second problem, inside of the sphere and outside of the cylinder. So if I look at a sphere, let me think, I'm debating if I should graph it inside. Yeah, that's okay. If I should graph it using GeoGebra. So let's say, okay, that's not working. Let me sketch it. So, when they say inside of the sphere, outside of the cylinder, we're talking about all of this region. Of course, it's all around. You can't see the background of this, but basically, you could say volume is the double integral over region D, and I'll get to D in a minute, of, and let's see how this works. This is going to run from the bottom. The bottom is negative the square root of 9 minus x squared minus y squared, and it's going to exit out of the top, which is the square root of 9 minus x squared minus y squared. I just put them in the wrong place. I'm thinking of the bottom is, so it's top minus bottom. Top would be the square root of 9 minus x squared minus y squared minus the bottom is negative the square root 9 minus I squared x squared minus y squared dA. And what that would leave me with, again, a circle, two concentric circles really, in which this is 1 and this is 3, almost identical to the previous region. The only thing that's going to change is what you're integrating, what the integrand is. And that's nothing more than 0 to 2 pi again, the integral from 1 to 3, r d theta whenever I convert. And this is really twice the square root of 9 minus x squared minus y squared, and it will be twice the square root of 9 minus r squared, nothing more than that. So this is nothing more than a u sub. You let u equal 9 minus I squared, du will be r dr. And there it is. We will get a chance of doing that same integral, those types in rectangular, polar, and we're going to add one more coordinates when we get to 3D, or triple integrals, I should say, cylindrical and spherical coordinates. Another problem, if I wanted to take, there it is, okay. If I wanted to take, and how does this look like again? This is z equal, and now we're picking everything in terms of z. Pretty soon we're going to change that. Z equal 4 minus x squared minus y squared, and z equals, so kind of like those are going to meet right there. And what we're looking at, the volume is going to be the double integral over region D, and we'll get to D in a minute, of what? And if I look at this, it's going to be top minus bottom. Top is the blue. That will be 4 minus x squared minus y squared minus the bottom, which is x squared plus y squared, and all of that over that region. And let's see, what is it really we're looking at? And if I take those and replace them, I'm looking really at 4 minus x squared minus y squared equal x squared plus y squared. So 4 equal 2x squared plus y squared, or x squared plus y squared equals 2. So I'm looking at a circle. That's what I see. And the radius of that circle is a 2. So now it's nothing more than simply r d theta, 0 to 2 pi, and I'm running from 0 to radical 2, not 2. And this would be what? This will be 4 minus r squared minus r squared, which is 4 minus 2r squared, but there it is. And it's a simple integral. I could integrate that, and that's pretty much it for this section.